Strange shapes look hard. Triangles hide inside them. Watch them appear.
Every shape in this stone den can be taken apart and rearranged. This landscape is a collection of geometric parts that fit together in specific ways. Watch the beaver organizing these logs and moss tiles. The mathematical quantities are built directly into the materials he uses to construct his home. Observe the physical geometry and animal action first. Seeing the quantities in the world makes it easier to name the mathematics later. Most complex polygons can be physically transformed into a familiar, easy-to-calculate rectangle. Success in calculating area depends on recognizing those internal structural connections within a shape. This parallelogram has a base of 8 units. That slanted outer edge is often where learners get stuck when trying to determine the total area. To find the area, we need the height, the straight vertical drop from top to bottom. In this case, that measurement is exactly 5 units. By cutting off the triangular section on one end and sliding it to the other, we can reshape the object into a perfect rectangle. This new rectangle maintains the original base of 8 and height of 5. Multiplying them gives us an area of 40 square units. Physically reforming the shape shows why parallelograms use the same calculation as rectangles, base times height.
Cut it into pieces. Find each easy area. Then add them up.
These two identical right triangles have side lengths of 6 and 4 units. Aligning their long edges and locking them together creates one complete rectangle. The area for this combined shape is easy to find. 6 times 4 equals 24. Since we only need the area of a single triangle, we must take that total and divide it by 2. 24 divided by 2 leaves us with 12 square units. A right triangle occupies exactly half the space of its corresponding rectangle, which is why halving is a required step in the formula. We can also find area on a coordinate grid. This triangle has vertices at 1, 1, 5, 1, and 5, 4. Look at the grid. Consider how to determine the exact length of the horizontal and vertical sides. To find the length, count the intervals between the points. On the horizontal axis, the value changes from 1 to 5. That horizontal change represents a length of 4 units. Vertically, moving from 1 to 4 gives us a side length of 3 units. Navigating a coordinate grid is a physical way to measure the dimensions of any shape. The moss rectangle, the clay triangles, and the reed coordinate grid all exist here together as parts of the same environment. Mathematical notation simply records the physical changes we see in the world. Observation is the primary tool of geometry. When we look closely at how shapes are built, the math becomes clear. Look at the marks on these stones. Which one proves the mathematical relationship, and how does the physical action of the animal make that relationship true?
Every shape gave in. Triangles solved it all. Try your own cut.